Hi everyone, welcome back. My name is Jake, and in this video we are going to talk about um, carbohydrates and everything from glucose, which is a monosaccharide, to our disaccharides like lactose, and our polysaccharides like amylose, glycogen, and um, cellulose. Okay, so let's just jump into it. Let's start by looking at our like original drawing of glucose and how we've seen it so far this semester. So thus far this semester, we have drawn glucose like this. And this is a way that you've probably seen it in other classes, and it's appropriate in some situations, but we actually have a different way to draw it in this class that helps us work with it a little bit better, and it's actually a better representation of how it looks. Okay, so let's just briefly kind of dive into how we got what we call a chair conformation. Okay, so what we'll do is I'm going to draw just the basic skeleton backbone of a simple six-membered ring that has an oxygen in it. Okay, and I don't want this to confuse people, but for some it might make a ton of sense. Okay, so we are going to look at it just like we did in Newman projections, from like our face is, we're looking at it, our face is in the screen, and we're looking at it from the red to the blue side. Okay, so that red carbon is going to be the front, and that blue one's going to be the back. Okay, and so what does that look like? Well, let's draw this. And are you going to be expected to do this with all glucose molecules? Probably not, but this will help you see the chair conformation. Okay, so we'll draw. And what's coming off? So those red ones are these guys here. Okay. Well, what's coming off of those carbons? Well, we have two hydrogens, and then we have this CH2 group there. Okay, so we'll draw that. And we have a hydrogen and another hydrogen. And another hydrogen and another hydrogen. Okay, so then what's going off of these blue carbons in the back? So back there. So those, the carbon will be behind it. And I'm dotting it so that you can know that it's behind. So it'll be like the carbon 2 or carbon 3 in our Newman projections. Okay. Well, what do we have coming off of it? Well, we have two hydrogens and an oxygen group off of each. Okay. So we have and this one didn't turn out very good. Going up like that. Okay, so I know that's a little messy and kind of hard to see, but that's kind of what we see when we look down the carbon from this perspective. Okay, why are we going through this? Well, this is a very good representation of our axial. Oh, I forgot to draw this carbon, this hydrogen down here. It's a very good representation, a way to teach axial versus equatorial. Okay, equatorial means in the plane of the sugar, so like in this plane, and axial is going up and down out of it. Okay, so these guys would be equatorial, and let's get a different color. This one and this one would be axial. Same here, axial, axial, while these guys are equatorial. Okay, so hopefully that makes sense to some people, but what it helps us see is when if we were to, it's hard when I'm using my hands right now, but if we were to like take this and like rotate it so we can see the bond between the red and the blue carbon, we'd actually get something that looks like this. Okay. It looks like that. This is what we call a chair conformation. Okay. And this is how we're going to draw glucose. Okay. So in glucose, all of our alcohols coming off of it are in the equatorial position. And I'll highlight this guy for a second. And this one, the one coming off of that carbon is going to be different. Okay. So first I'll draw it all in the equatorial position. Okay, so how do we know it's equatorial? Well, if the alcohol coming off of it is parallel with the bond that's one away from it. So we skip this one and we see that these two are parallel. So let's check if this alcohol is, let's check if this alcohol is equatorial. Well, those guys are parallel and we skip that bond there. This one is parallel, skip that one with this one. And then this one is parallel with this one here, and we skip this one. That's also, if we can go this way too. Okay. So this is glucose. Okay. And I want to highlight this carbon here. This carbon is called the anomeric carbon. And so let's write it. This is the anomeric carbon. It's important because it is in the aldehyde oxidation state, because it is bonded to two electronegative elements. And its alcohol can change from the equatorial position to the axial position, and it'll still be glucose. So when the anomeric carbon, when the OH group is going up like that, that's what we call beta glucose. When the anomeric, so let's say that this alcohol is going down like this in the axial position, we call that alpha glucose. Okay. So right now, up to this point, you should be able to, you shouldn't have to look at this and then go to this, and then from this, go to this, and then rotate this to turn to that. What this is showing you is that this chair conformation isn't like very abstract. It's a pretty accurate way of looking at glucose and other monosaccharides, okay? So up to this point now, you should be able to draw a chair conformation of glucose that has alpha or beta. Okay, so let's do that. So here, let's draw alpha glucose, and then we'll do beta glucose. Okay, so and again, these are not bow ties. Okay, so when I say bow ties, they don't look like this. We do not want to see that. We want to see, and I apologize, sometimes mine aren't as good as they should be, but so we're drawing alpha glucose. So alpha glucose has all of these alcohols like that in the equatorial position. Okay, while alpha means that the anomeric carbon, the alcohol coming off of it, is going to be in the axial position, which is either up or down. And in this case, it's down because it's carbon number 1. Okay. On the other hand, beta glucose is, we'll go ahead and draw it. Is, oh, it doesn't look very good, but is where the anomeric carbon position, the alcohol is going in the equatorial position. So that is going to be alpha, and this direction is going to be beta. Okay, great. So moving on, the next one we need to learn, and let's change colors, is galactose. And we can also have alpha galactose and beta galactose. Okay, alpha galactose that doesn't look very good. So alpha means that the anomeric carbon is in the alpha position, and galactose now changes this alcohol to the axial position. So it goes up like this instead of glucose originally going like that. Okay, so that's not how you do that. Okay, so this would be alpha, and then galactose is that sugar going up. Okay, well, what's beta galactose? It's pretty easy. Let's we'll copy this one. And it's where the anomeric carbon is in the equatorial position. So we'll run through this again. Alpha, and we have galactose, and that one makes sense. So we have beta, which is the anomeric carbon, which is carbon number 1, is in the equatorial position, and then galactose means that our alcohol group on carbon number 1, 2, 3, 4 is going up in the axial position. Okay. The next one we need to learn, and do black here, is alpha mannose. And then beta mannose. And this is where carbon number 2 is going to go up. instead of equatorial. Okay, so let's draw that. So alpha mannose. Alpha, meaning that anomeric carbon's going down. Oops, sorry, I get a little ahead of myself here. I end up drawing glucose again. And this one takes a little bit of artistic ability because this guy is going to go up like that. And depending on the semester, sometimes he draws it all the way up like this, or you could, I think it's okay or appropriate to draw it up like that in the middle there. Okay, so for this video, let's draw it all the way up like that. Okay, so that would be alpha mannose. And this guy here is going to be beta mannose. Quickly review that. So alpha, meaning that the anomeric carbon is going down. Mannose, meaning that the carbon number 2 is going up. Okay, so we're basing it all back to glucose. So all the other ones are going to be in the position of glucose. Okay. And then beta mannose is going to be the anomeric carbon going in the beta position with the carbon number 2 going up as well. Okay, so remember alpha and beta can be for all of our monosaccharides, mono meaning 1. Okay. So these are, commit these to memory. And let's do a quick little conversation here about carbohydrates. Okay, so carbohydrates mean sugars. That's what you need to think. It means, that's not what the name actually means, but these are things that you should think about when we talk about carbohydrates. You should think that they're made of sugars. Made up of sugars, that they provide energy. Okay. And the types we have, and I apologize for spelling, monosaccharides. And then we have disaccharides. And then we have polysaccharides. Okay. These and I apologize for those red dots that show up, but these monosaccharides are going to be like glucose that we just learned about. And remember, all of these can be in the alpha or beta conformation. So we have glucose, galactose again in the alpha, beta, and mannose. Then we have disaccharides, which is 2 sugars. And we'll get to that. And then we have polysaccharides, which is 3 or more sugars. Okay. And we'll talk a little bit more about these as well. Okay. So hopefully this video gives you a good little introduction on sugars. The last thing I want to talk about, and let's move to this section. Just like we learned when we drew our original form of glucose, we learned that carbon 1, carbon 2, whoops, I never drew the alcohol here. Carbon 3 and carbon 4, carbon 5 are all stereocenters. Okay? So that means that when you change, let's say this is a wedge, and we were to change this to a dash, that would change it, let's say, from S to R. And we're not assigning this S as it is and then wedged being R. I'm just saying that if it was S, it would change to R. Okay, you're not required to in this class to assign the stereocenters on this molecule. Okay, but you understand that you would be able to draw the enantiomer, which is where all the stereocenters are flipped, and you should be able to draw the diastereomer, which is where one, some, but not all are flipped. Okay, so let's go back to this sugar molecule I'm drawing. Here we don't have wedged, and I'll draw this one in the beta form. We don't have wedged or dashes. But what we need to understand is that carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5 are all stereocenters, like we saw in this guy here. Okay, even though that we don't show the wedge or the dash. You're not required to tell me S versus R when we're using the chair conformation because you have to use different rules. But what you need to understand is that this can have an enantiomer and diastereomers. So the relationship between these are all diastereomers of each other because some but not all of the stereocenters are flipped. For example, if we compare these two with each other, this stereocenter changed from beta to alpha. So one of the stereocenters changed. That means these are diastereomers from each other. Here we have alpha and beta glucose, again, diastereomers because just one stereocenter changed. If we were to compare these guys, right, we have one stereocenter that's different, and 2. So one, some, but not all. So some of the stereocenters are changed. So all these are diastereomers of each other. Okay. And then lastly, a lot of the times when we draw any of our sugars, if it's not explicitly stated alpha or beta, we draw the anomeric carbon with this little squiggly line because it means that it can be an alpha or beta. What we're going to learn shortly in class is that there's a mechanism, and it's actually very easy, but it interacts really well with water or acids and bases, and it switches it back and forth between alpha and beta. Okay, so let's just say we had a cup of water that had glucose molecules in it. Let's just say 50% of them are in the alpha and 50% of them are in the beta because they're switching back and forth in water, okay, between alpha and beta. So unless it's explicitly stated that you must draw the alpha glucose or the beta glucose, it's perfectly appropriate and correct to draw it with this little squiggly line, meaning that it can interchange between beta or alpha. Okay. So that's a quick little introduction on monosaccharides and carbohydrates. And we'll make a video part 2 encompassing disaccharides and polysaccharides. Hopefully this was helpful.